Okay, so let's talk about the Rates law. The Rates law of chemical equation. The Rates law of chemical equation. What exactly is the Rates law talking about? The Rates law states that what? The rate of chemical reaction is directly proportional to the concentration of the reactant. Take note. Is directly proportional to the concentration of the reactant, meaning that if you have a reactant A plus B to give C, how will you write the Rates law? The Rates law is directly proportional to the concentration of the reactant. Please, product is not concerned because it is our reactants that we even use to determine the rate of equation. So because we use what? Concentration of the reactants A, then B. And take note, anytime we are making use of concentration, we always make use of the square brackets. By the time we are using mathematics brackets will not work here. We make use of what? Of the square brackets. So for every proportionality, there must be a constant. For every proportionality, there must be a constant. That is what we know in mathematics. So I will now introduce a constant. R is equals to K, concentration of A, then concentration of what? Of B. Raised to power each exponent. This is a typical what? A typical Rates law. So the Rates law states that what? The rate of chemical reaction is directly proportional to the concentration of the reactant with each exponent. Your X and Y, they are the order of reaction with respect to reactants A and reactants B respectively. So your Rates law. So please, in this particular Rates law, you can determine your order of reaction by just noting that your X is the order of reaction of A, your Y is the order of reaction of B, your X plus Y is the order of reaction of what? Of the overall, is the overall order of reaction. Am I communicating? So this is how it is. Your R is equals to K, concentration of A raised to power X, concentration of B raised to power Y. That is how we write our Rates law. So please, no matter how any equation that you were given, just try to note that what, if you are asked to write the Rates law, try to note what exactly you are writing, because this particular X and Y can also be equal to the number of moles in front of each of them. Just like now, let me write a particular hypothetical equation. We have 2A plus B to give me 3C. If they now ask that what is the Rates law of this particular reaction, for me to be able to write the Rates law of this particular reaction, then I can say my R is equals to K into bracket A raised to power 2, then B raised to power 1. At the end of the day, my order of A is equals to 2, order of B is equals to 1, then overall order of reaction is equals to 2 plus 1, which is equals to 3. So automatically this reaction is equals to what? Is equals to 3. Now, what are the conditions for writing Rates law? We have some differences between our order and molecularity. Order can only be experimentally determined or gotten from an elementary reaction. Take notes. Order can only be what? Experimentally determined or gotten from an elementary reaction. You cannot just get order like that. You cannot just get order. No, they can't just give you a particular reaction, then they say A plus B to give C, then look for the order of reaction. It's not possible because it's not molecularity that we can only see that okay, this particular molecularity of the reaction is 2. No. How we can get the particular order of that particular reaction is that they must tell us that this particular reaction is what? Is experimentally determined, or it is what? It is an elementary reaction that cannot be further be breaking down again. So if they give me this particular equation, and they did not put the phrase of what? Experimentally determined, or it is a what? Elementary step, I must not write the Rates law. I cannot write the Rates law. Because that means that this particular reaction has to undergo some processes because before I can write the Rates law, but I can further write the molecularity. The molecularity is equals to 3. That's the difference between molecularity and order of reaction. Good. And also, let's try to explain what we mean by the word. The RDS or RLS, people always mix it together, but for your level is the same thing. When we are trying to study chemistry all over, maybe doing 256, 356, then you know the difference between them. But for 100 level, it's still the same thing. We have what we call the rate determining steps. The rate determining steps, or the rate limiting steps, they are still the same thing for this level per se. So we're talking about the rate determining steps, the rate limiting steps. You know, if I give you a particular reaction, A plus B to give C, A plus C to give D, then A plus what? Then C plus E to give F. Then I say that my final reaction is what? Is A plus C to give F. Automatically, this particular reaction comes from the combination of this particular reaction. All those, each of them are their elementary reaction, and each of them are elementary steps. I now want to try to look for my rate determining steps. My rate determining step will not be getting from the slowest elementary steps, because they will tag them. They can say that this one is slow, this one is slower, or this one is what? This one is slowest. So it is this particular slowest step that we use to write my rate law and also use to determine my order of reaction. They can also change it again. They can also change it. Okay, I write fast, faster, and fastest. Then the question comes, which one is the slowest? As a smart student, yeah, this one is slow because these two reactions are faster than this. So it is always the slowest elementary steps that we always use to write our rate law. So that if I want to write the rate law of this particular reaction now, then I will focus on this step 1. Because it is step 1 that will not determine the rate of chemical reaction. Then I cannot write, they cannot say my rate of chemical reaction for my rate law for this reaction equals what? The rate law equals to K into brackets A, then into brackets B, right. This is my rate law. This is my rate law. If I said I can look for the order, right? Then the order of A is equals to 1. The order of B is equals to 1. Then the overall order is equals to what? Is equals to 2. So automatically this reaction is what? Is the second order. So that's what we call the rate determining steps. Please know, you must know, you cannot just write your order or rate law without them giving you an elementary reactions, or the third what that particular reaction is determined experimentally. Because for you to get your order, you are going to get your order using rate law, right? And for you to get your order is what? Experimentally determined. In my next video, I'm going to show you how to calculate order of reaction using experiments. So that is how you have to understand the rate determining steps and the rate limiting steps. So let's talk about the what? Differences between order and molecularity of the reactions. Order versus molecularity. When we are trying to do, based on definition, order is the sum of exponents in a rate law. The sum of exponent of each reactant in a rate law. You know, I told you that if you have a rate law of K into bracket A into bracket B, then X and Y. X plus Y is the overall order of reaction. Based on definition as well, we're talking about molecularity. Molecularity is what? Is the total number of moles, ion, atom of a particular reactant in a particular reaction. If I have A plus B to give C, then I can say my total molecularity is 2. Am I communicating? So that is just it. And also, your order can be what? Your order can be negative. Your order can be negative. Yes, we have negative order. In subsequent videos, I will be explaining that. But your molecularity can never be negative. Your molecularity can never be negative. Because can you tell me that it's minus? No, you can never have a reaction that has minus A plus. No, it's not possible. So your molecularity can never be what? Negative. Difference 3 is that your order can be 0. but your molecularity can never be 0, because that was the reason why we said even in a particular reaction that has more than 3 moles of reactant, then we say molecularity does not exist, rather than saying molecularity is equal to 0. Molecularity can never be equal to 0. Am I communicating? And also, your molecularity is gotten from the stoichiometric mole of the reactant. While your order of reaction is gotten from the what? From the experimental determined reaction, or what? Or an elementary steps. That's the differences between your order and molecularity of a reaction. So in this video now, we've explained a lot of things. We've explained the rate of chemical reaction, we've explained the rate law, we've explained molecularity, we've explained the mechanisms, we've explained elementary reaction, we've explained the overall reaction as well. We've already explained the rate determining steps. So I just want you to know this before I come back for my next video. We have 3 common types of order of reaction. Order of reactions. We have 3 common order of reactions. We have the first order reactions, the first order reactions, the second order reaction, the second order reaction, and the third and the 0th order reaction. Those are the common 3 order of reaction. Let me tell you, we have 0th order, we have negative order, we have fractional order, we have pseudo order, we have third order, we have fourth order. But for your level, limit on this: the first order, the second order, and the 0th order of reaction. And also for molecularity, we have the unimolecular, bimolecular, and termolecular. Note, if your molecularity is 3, it's not trimolecular, because that's what students is fond of. Anything 3, try. No. It's termolecular. Any molecularity that is more than 4, that is more than 3, like molecularity does not exist. So thank you very much for watching. Thank you very much for, please, after you watch, share, subscribe, and like this video. See me in my next video.